Welcome everyone. Welcome to this presentation. I'm Matteo Bigliani, the technical application engineer from Dobol, ISA. And today we're going to look at this presentation. So we're going to talk about circuit breakers testing, the evolution of the best practices. This presentation is divided in 3 different topics. We will start with an introduction of the circuit breaker functionalities. After that, we will talk about the maintenance aspect of the circuit breaker. And at the end, we are going to see the testing equipment and testing methods that we provide with our solution. The presentation will last about 40 minutes. After that, we will take some time to reply to your question. So if you have some question, you can write directly into the chat. At the end, if you want, you can participate to the survey that we will provide you. For more complex question, you can write directly to me. You can see my emails here, and I will show it also at the end of the presentation. So we can start. The first topic is an introduction of the circuit breaker, so how they work and how to test them. Okay, what is a circuit breaker? Basically, it is a automatically operated electrical device. It is basically designed for 2 main purposes. The first one is to sustain the current, the load current during its normal operation. So if there is no fault in the line and no fault in the circuit, you just have to sustain this current. The second purpose is to interrupt the fault within the fastest possible time. So in case of a fault, it needs to open very in a fast way. Here you can see a simple, very simple example of what happened during a fault. You can see that we can show a fault on the transmission line. This fault, the voltage and current fault, is detected by the voltage transformer and current transformer. And this signal is sent to the relay. So the relay is able to recognize that there is a fault in the line, and the relay send an open command to the circuit breaker that and it should open in the fastest way possible. What happens when the CB opens? You can see here we have the time. We can see that in a closed position, the circuit breaker is closed and the current, the load current can flow within the 2 chambers of the breaker. If a fault occurs, the CB starts to open, and in the stable condition, the CB is totally open, so we have no current flowing into the chambers. The most critical part is this situation in which the 2 chambers of the CB are very close to each other, and so we can have an arc that must last in very short time. In fact, this electric arc can damage the conductors if it stays for too long So the circuit breaker must be able to reduce the arc within a short time. Okay, you can see here that in a normal situation, the load current that must be interrupted is about 100 or 300 amps usually. So the arc that is formed in this condition is not so dangerous. In fact, the main contact is designed to withstand hundreds of interruption, so you can open and close hundreds of times in nominal situation. The problem is when we have a fault. In that case, the fault current is much higher than the nominal one. So in this case, the main contact can withstand only a few interruptions of this fault current, and after each opening in this situation, the CB is damaged, gets damaged, and must be checked. So we can see later how to do it. One possible way to reduce the arcing, the electric arc, is to use the arcing contact. In fact, its main purpose is to extinguish the arc that is created in the first millisecond of the operation. It is just composed by this. It is a metallic contact that has a higher resistance than the main one. The main contact resistance is about microohms, while the resistance of this arcing contact is some milliohms. This allows to reduce the electric arc during the operation, because we can see later, but the arcing contact remain closed for a longer time than the main one. So there is a little bit of time in which the current will flow only in this arcing contact. So this method allows to reduce the arc that is formed in this faulty condition. Another way to reduce the arc is to use the SF6 gas. As you can read here, is a non-flammable and poisonous gas that has a much higher interrupting power than the air. So what is done is to compress, to put a compressed SF6 in the chamber of the circuit breaker, and this allows to have a more compact circuit breaker, so you can reduce also the space, but also it allows to reduce the electric arc, because it increases a lot the insulation between these two contacts. Okay, let's take a look on other CB characteristic. We have the number of chambers. You can see here that for medium voltage and high voltage, usually up to 300 kV, we have only one chamber that interrupts the current. For higher voltage, so up to this value, 550 kilovolts, we can have two chambers, two different chambers that interrupt the fault current. Also, for higher voltage, we can have more than 2, 4, 6, 8. The purpose of this chamber, you can see down here, is to divide the fault voltage between more components. So you can see that if you have only one, all the fault voltage and fault current will be interrupted by only one element. If you have more than one, the voltage is divided by the number of chambers that you have. So the single element must sustain a lower voltage in this case. We also have grading capacitors. These allow to divide the voltage to make a constant voltage between all the elements, so to avoid some instabilities between them. Then we have the cabinet. You can see here. In this cabinet, you can find the manual open and close commands and also all the terminal of the coils. So you can have access to the open and close coils, auxiliary contact, and all the contact that goes to the relay. Open and close coils, you usually in low voltage you have just one open and one closed coils. For medium and some high voltage breakers, you have also one open and one closed coil, but with two different circuits. And for extremely high voltage, you can usually find 3 coils for the open each phase and only one close coils. There is also the possibility to have 3 open coils and 3 closed coils, but it is not so usual to find it. The commands can be done, can be sent locally. So you have the button to press to open and close the breaker. They can be done remotely in the control room, or usually the CB is open and closed by the relay, so by the protection system. The auxiliary contact are instead used to define the position of the circuit breaker. So it is an information that is given to the relay, to the control room, to verify the position of the CB. Another another element that we can find is the PIR, is a pre-insertion resistor. It is very similar to the arching contact, but it is used only when during close operation, not during open operation. So basically, it is made. It is a resistor with higher value than the arching contact that is used during closed. So it closes a little bit faster than the main contact. Okay, we can see here that medium, some example of medium voltage breakers. They always have only one chamber. And we can see the operating chain of the of an open commands. Okay, let me take a bit because it's loading the slides. Okay. Okay, you can see that the CB include a motor. This motor charge the springs that will be used to operate during an interruption. So the motor charges the spring and the energy is stored using a spring. When you have to open the circuit breaker, the coil commands provide the command to open, And so the spring releases its energy to all the mechanism and leverages that allows to open the main contact. After each time that you open the breaker, the motor will continuously charge the spring. So you must have, in the spring, you must have enough energy to operate in the most critical condition that usually it is an OCO operation. We will see later. At last, when the breaker contact is open, we have the auxiliary contact that follow the status of the main breaker. These are usually two. One is normally open and one is normally closed, and they give the substation devices, such as a SCADA or relays, the status of the main contact. Okay, let's talk about maintenance. Okay, we can find here the indicated with number 1 the routine maintenance, with number 2 some simple procedure that you have to do or you can easily implement, and here some description of what you have to do. You see the easiest one is a visual inspection. So if you see it is not in a good condition, is corroded or something like this, you have to do it annually. And also you have to check the counter reading. So this is a counter that increases each time the CB operates. Then some simple procedure like this one. So checking oil levels, checking tightening the connection, and all of this. Some more complex procedure can be found here. So this one with level 3 required some complex equipment, like the checking of the check of the synchronism, and also the 4th level require both an equipment, a specialized equipment, and also the knowledge to perform this type of check, like measurements of the electric losses, main contact static resistance, dynamic resistance, and also the measurement of the timings. We have the same in case of SF6. Okay, in this case, we have a different type of checks because we also have to check the gas quality control. And again, the same for GIS, so gas insulated switchgear. Okay, within all the operation that we just saw, we saw that a lot of them required some equipment, like this one, so the check of the times and synchronism, the static resistance measurement, and the dynamic resistance measurement. All of these can be done with our circuit breaker analyzers, that are these. So we have CBA 1000, CBA 2000, and CBA 3000. Okay, we can see the main differences in this slide. Okay, you can see that all of them can test up to 2 break per phase, but up to 6 break per phase with CBA 1000 you cannot do it. If you have more than 2 breaks per phase, you have to use CBA 2000 or 3000. The static and dynamic contact resistance can be done with all the 3 models, but CBA 3000 has a 3-phase generator, so it is faster to do it with these devices. The device. Travel transducer, CBA 1000 has only one available. CBA 2000 has 3 analog or 3 digital. CBA 3000 can have 4 analog or 4 digital. Then we have the condition of both side grounded in air. This means that this is a situation that is done for a safety reason. So basically, you connect to the ground both sides of the CB. In this way, you can avoid, for safety reason, you can avoid if you have a fault in the line while you're doing the maintenance. In this way, you are protected against this type of situation. This is more difficult to test in this condition because both sides are connected to the ground that is connected to the ground grid. The ground grid has a quite low resistance, so that goes in parallel to the main contact one. These give some difficulties when you test it, because basically you will see that the breaker is always closed due to this resistor. CBA 3000 can test it up to 2 breaks per phase in this condition, while CBA 1000 and 2000 can test it with 1 break per phase situation. This is a new option. We will talk about this later. At last, we have the both side grounded with GIS, so gas insulated switch gear. This can be done only with, can be tested only with CBA 3000. Okay, the main feature with CBA 1000 and 2000. The basic features are the test of times, open, close, all the operations. We can, these devices give the trend of the energizing current, so the close and the open coil currents. They give you both the trend, so you can, it is automatically calculated the duration of this current flow, and also the peak of this one. And we also, you can also use the calculated the time of the auxiliary contact. As we saw, you can test it up to 2 breaks per phase with CBA 1000 and up to 6 breaks per phase with the 2000. It is one of the main differences between them. Optional, you can buy the current generator up to 200 amps that allow to make the static and resistance measurement and the dynamic one, minimum trip coil or thermal printer. So you have the possibility to choose between one or the other. And also the possibility to use external accessories like a transducer, pressure transducer, travel transducer, clamps, and so on. As we said before, we have a new feature that is the possibility to test both side grounded condition with external clamps. CBA 3000 it is a little bit different because it is a new one with new technology. You can see some differences. The main difference of this device it is that it is completely configurable. So you have the same basic feature, but you can test up to 8 breaks per phase optionally. Some options are basically the same, but we also can test GIS, as we saw before. We can see here some main features. So to break per phase timing inputs, this one, for phase A, B, and C. Auxiliary inputs, we have up to 4 of them. Here we have first trip testing coil or the thermal printer. Okay, we have the display here, micrometer up to 200 amps generator. This one is for travel transducer or other options. Coil commands, close, open, up to 3 open coils. CBA 2000 is very similar to the 1000. The main difference is this part. It has more than just one timing input. It has up to 6 breaks per phase, so 12 inputs. I mean, 6 inputs for each phase. The same for auxiliary. And the other difference is this part, because with CBA 2000 we saw that you can use up to 3 travel transducer. CBA 3000 is different. It has a different display, different way to configure the device. We have up to 24 inputs that can be set as main contact or auxiliary contact as you want. You can choose for each input. 2, 4, or 6 coil commands, and 1 or 3 up to 3 micrometers. That is different than the CBA 1000 and 2000, which has only 1 maximum. The advantages of CBA 1000 and 2000 is it is very simple, convenient, and intuitive. We don't have external options. Okay, it allows to make all the basic measurement easily. You can have an internal printer, or you can use it, command it with a software, so you can print your report in an editable way and quite fast. Okay, internal memory. The main difference, one of the biggest difference between CBA 1000, 2000, and CBA 3000 is that the 1000 and 2000 can be operated using a battery, so you don't need to connect the power supply. CBA 3000 doesn't have this, so it must be connected to the power supply always. CBA 3000, it is also quite simple to use. Also, it has a test wizard that allow you to configure it as you want. This is the same as 1000 and 2000. One of the main difference is that it has up to 3 micrometers, so you can make more than 1 measurement in a single cabling. So you just connect all the cables and you can perform all the possible tests in all the 3 phases. While on CBA 1000 and 2000, you have to connect 1 phase at a time. And also one main difference is that it can test GIS. Okay, we can continue with looking at the test method. So how to test the circuit breaker with our equipment. Okay, we can start with air insulated switch gear. So the classic method. The classic method to measure, to to verify if a contact is open or it is closed is by measuring its resistance. If the resistance is equal to the contact one that we expect, this one is closed. If it is closed equal to infinity, of course, the contact is open. As you can see here, you just have the graph of the resistance until the resistance is equal to the contact one, the CB is closed. Once it goes to infinity, the CB is open. How can we measure it? We just generate a voltage between these 2 points, and we measure the flowing current. If the current is greater than 0, the contact is closed. If it is lower, if it is 0, the contact is open. The resistance contact that we expect is very, very small, so few microns. So basically it can be considered as a short circuit. And the connection to do are just this one. For each phase, you can take the timings. You connect one on one side of the breaker chamber and the other one to the other side. In case of 2 break per phase, you just have to use 2 of them. Here, an example and some picture of the connection. In this case, it was just 1 break per phase. One clamp is connected here, and the other one is connected up here. These 2 correspond to these 2 inputs. This is the result that we expect. Of course, to perform open and close tests, we have to check also the open and close current from the coil. So we provided, in this case, a close commands. We measure, so we detect this trend of the current, and the close time of phase B is calculated as this point up until the contact closes. The same for phase A and C. In this example, phase B contact closing time is lower than the other 2. Exactly the same for the opening. In this case, we just give an open command and not the close one. This is valid for a single operation, but usually the worst case is not only just an open and close operation, but we have more than this. That's because we have a different type of fault. In the usual situation, when you have a fault, it's just a temporary one. So maybe lightning strikes on the line, so it is just a temporary fault. After that, the fault disappear. So the usual operation is to open the circuit breaker when the fault occurred, but try to close again after some time. It can happen also the opposite. So in the case that the fault is permanent, so in this case you just have to make it is possible to make you have to open again the circuit breaker after the closing cycle. So you see the fault, you open, you try to close again to see if the fault is gone or if it is still there. In the second case, you have to open immediately again. So the operation that you do is the OCO. This operation is the most energy depending operation that you can do, because it operates 3 times within a very short time. So the spring must have enough energy to completely perform this operation. So repeat again, you see the fault, you open the circuit breaker, wait some data time that can be, in case of fast the closure, 300 milliseconds, in case of a slow one, 30 seconds. Of course, the fast reclosure is the most critical. Open, wait 300 milliseconds, close again, and you see immediately the fault is not gone, so you open immediately again. These two commands are given at the same time, basically, so they can be overlapped. We can see here the operation: open 0.3 seconds, close and open again. So we expect this type of results. As we see before, both of the close and open commands are given, are overlapped, but there is a mechanism on the circuit breaker that put a delay in the open operation. Okay, we can see here the results. Okay, let's talk about this interesting new feature. It is a clamp that can be used with CB 8000 and 2000 to test the BSG option, BSG situation. It is very easy to use because you can connect it directly in this point, so you don't have to go up in the circuit breaker. You can just connect it to the ground connection, and allows you to check the timings directly from here. So when the CB open and closes, you can check its timing without connecting the timing to the circuit breaker. Is a extremely compact setup. There are just 3 clamps, so you can just connect them like this. So it is very easy to use. Okay, let's make a very fast presentation of the GIS. In this case, the problem is the same that we have in BSG. So you have a parallel resistance connected to the main contact. In this case, it is also a critical condition because the value of this resistance is much similar, much lower compared to the BSG situation. So this value is very close to this one. In this case, to check the open and close operation, we just have to use a Rogowski coil. This one give a peak, a signal peak when you have a transition between the open and close position of the CB. So in this way, we're able to test also the GIS cases. Okay, let's talk about static resistance measurement. It must be checked because if the resistance increases in the contact, this means that it is a sign of deterioration of the contact. So the heat and the power loss increases in that phase. So we just have to measure it. The good way to measure it, okay, we cannot use the 2-wire method because the resistance we saw it is close to some microns. So this way it's not possible to have valuable results because the 2-wire method consider also the resistance of the wire that you use. So it's not possible to use this method. But it must be done with an external generator. So we have to use the 4-wire method. We also have to use some other precaution, like the position of the terminal voltage. It is fundamental to position them in the correct way. We have to use enough current generation. Okay, current must be stable, and we have to react the noise in a very good way. You can see here that, okay, I'm jumping some slides. You can see that the position, if you connect like this, you can obtain a value. If the position of the voltage measurement changes, in this case, you obtain a different value. So it is extremely important to make the good position. In this example, it is a real testing. You can see the important one is the position of this voltage clamp. In this case, you can see that it is not close to the CB, and the result obtained is 100 microamps. Just by changing the position closer to the breaker, you can obtain a totally different results. Here are some example of connection. The test current must be high enough. In fact, we can generate, usually it is recommended to use 100 amps. With all of our instruments, we can generate up to 200 amps. The most easy, the most simple way to use 100 amps, reason to use 100 amps is because it is much easier to measure 2.8 millivolts instead of 280 microvolts. This value is much easier to be measured. Also, we have a Seebeck effect and other type of things that can be neglected with 100 amps. Current amplitude must be stable. That's clear. And also, we have to use some noise rejection. We can simply fix this using shielded cables and filtering digitally the signal, the induction signal at the line frequency. Okay, I go quite fast. You can see here the connection that you have to do to perform this test. They are the same for static resistance and dynamic resistance. They are the same for both CB 1000, 2000, and 3000. Okay, let's talk about dynamic resistance. The main reason to do this test is to measure the arcing contact, because we saw that each time that the CB opens during a fault condition, this arcing contact burns a part of it, so it reduces its length. The dynamic resistance is made exactly like the static one, but the CB opens during the generation of the current. So you can see that situation one, both main and arcing contact are closed, so the resistance is close to some micro ohms. Once it starts to open, in this case, the main contact, you can see here and here, is opened, but the arcing contact is still closed. So we find something like this. The resistance is no longer microohms, but it goes to the arcing contact resistance that is about milliohms. Once it is fully opened, we have infinite resistance. So we expect some result similar to this one. The arcing contact length can be evaluated with the duration of this part. Usually you must compare this result with the previous one to see if this duration is shorter than the year before or something like this. So if it goes from 2.9 milliseconds to 3. I mean the opposite. If it goes from 3.8 milliseconds to 2.9, it means that this part of the arcing contact is no longer present. So you can compare both results to see the condition of the arcing contact. Actually, the duration is not a good way to evaluate this. In fact, you should evaluate the length, so in millimeters, not in milliseconds. You can do this by using a travel transducer together with this test. For the close operation, it usually is not required to make the dynamic resistance measurement because you cannot find a very good results. This depends on the difference between the close and open contact is very, very high. So you cannot have a good result in this case. The dynamic resistance also allow you to see if you have bounces in the trend of the CB. So if you have bounces, you can also verify it with using this test. Okay, I finish with the presentation. I can check if you have some question. As I said before, if you can always write to me for more complex question to this email. Okay, let's take a look. Okay, give me a second because I see it in very small. Okay, I ask you to be a little bit patient because I have some problem with the visualization of the question. Okay. Okay, let's take a look. Okay, Ryan asked if CB8000 has a direct PC interface. Yes, you can use it. You can use all the free CBA using the local screen or connecting with the PC. So you have the two possibilities to test with these devices. Then Yusuf asks, how critical is the clamp connection to the CB position? It is very critical in case of static resistance measurement. As we saw, the voltage clamps must be very positioned in a very good way. Also, the contact between must be very clean because you can have a different result if the position, the contact is not clean. In case of timings, it's not critical at all. Okay, then I see how much should be the amplitude of the current for dynamic resistance measurement. Also, in this case, it must be about at least 100 of amps. In this case, actually, it changes a bit during the test because when the CB is open, you cannot generate current. But when it's closed, it must be enough. Usually it is 100 amps. Then I have a question from Salem. It is acceptable to do contact resistance test for GIS breaker without using a dual ground method? This is not possible if the GIS breaker is installed, because you cannot physically disconnect the dual ground. You can do it if you uninstall the CB, but in a common situation, it's not possible to remove them. So for GIS, you cannot, you have to test it in this method. Okay. Okay, the last one is, I can reply, is where is the best place for connecting the voltage clamps? As I said, for static resistance measurement, the best place is closer, as close as possible to the main breaker contact. And again, you have to clean the contact before position the clamp. Okay, for all the other questions, you can write a mail to me. Again, I can repeat my email. You can find it here, and I will reply as soon as possible. Okay, thank you to attend this meeting. Have a nice day.